Welcome to Study Loop.
We want to find values of a and b for the following limit as x approaches 0 that makes it equal to 0. So if we want this to be true, well, first let's go ahead and just simplify this a little bit. So the first thing we can do is distribute it across the pluses. And really, I'll just go ahead and group it like this to start. So the limit as x approaches 0 of sine of 2x over x cubed. And actually, I'll go ahead and combine these two just by adding them really quickly. So in the numerator, that's going to be plus bx all over, and then we'll have the x cubed. Right, so we'll have that, and we'll have plus the limit as x approaches 0 of a is equal to 0. And we know that a is a constant with respect to x, so this here will just end up being a. So we can go ahead and subtract that over. And so we'll get negative a is equal to the limit as x approaches 0 of sine 2x plus bx over x cubed. Okay, so we have this now. Now, if we were to just plug this in directly, well, we're going to have 0 there, 0 there, and 0 in the denominator. So we have 0 over 0, which means we can apply L'Hopital's rule to this. So for this next step, we're going to apply L'Hopital's. And so that's going to give us that the limit as x approaches 0 of, well, the derivative of sine is cosine 2x, and then we have to apply chain rule, so we take the derivative on the inside, so we multiply that by 2. And then we take the derivative of bx, which just leaves us with b, and then in the denominator we'll have 3x squared, and this here should still be equal to negative a. Okay, now if we were to apply the limit directly, so cosine of 0 is 1, so we'll end up with 2 plus b, and then in the denominator we end up with 0. So we still can't divide by 0, but we want this limit to hold. So that means, so this implies we want our numerator to also be 0. So we're going to want 2 plus b to be equal to 0, which implies b is equal to negative 2. So we found one value, so I'm just going to go ahead and put that up here at the start. So b is equal to negative 2. And now we can go ahead and plug that in for b. And doing that will give us something that we can take the derivative with respect to, or apply L'Hopital's rule, since we'll have 0 over 0. So I'll just go ahead and apply L'Hopital's rule again. So that's going to be the limit as x approaches 0 of, so we're going to have 2, so the derivative of cosine is going to be negative sine 2x, and then we have that 2 on the inside that we have to take the derivative, move that out front. So this 2 would actually become a 4. And then we divide this by, so we'd get x, and then we have to move that 2 out front by power rule. And so then we'd get 2 times 3, or 6. Okay. Now, if we were to apply the limit here, again, sine of 0 is going to be 0. X is just going to be 0. So So we can apply L'Hopital's rule one more time, and I'll go ahead and move this up here. So by L'Hopital's rule again, oh, and actually, one thing I should still have over here is that the right-hand side of our equation should still be equal to -8. All right. So now, using L'Hopital's rule, the left-hand side is going to become the limit as x approaches 0 of, so we take the derivative of the numerator again. So the derivative of sine is going to be cosine 2x. Then we have to take the derivative with chain rule. So we'd end up with another 2, multiply that by the -4 we already had, so that becomes -8. And then in the denominator, the derivative of 6x will just be 6. And this here is still equal to -8. Now we can go ahead and apply the limit again. And again, cosine of 0 is going to be 1. So we'll end up with -8 over 6 is equal to a, or -a. So we can multiply the negative over and simplify 8 over 6 to give us 4/3. So we end up with that a is equal to 4/3 and b is equal to -2.